Okay, so this is an example of a sodium thiosulfate titration question. I've summarised the question really briefly at the top. So the question is to do with a sample of iron 3 ions, okay? So we've got 16.95 grams of an iron 3 compound, okay, is dissolved in 250 centimetres cubed of water. And the question wants to know what is the percentage of iron in that sample, all right? So my previous video spoke about what we actually do during our sodium thiosulfate titration itself. So this is then just another example where we want to work out basically how much of this we have. We're going to perform the first reaction. We then take the iodine that's made and we titrate it against our sodium thiosulfate, okay? So that's what's been done. And our sodium thiosulfate then this time was 0.133 molar, okay? And it came out that our mean titer was 26.45 centimetres cubed. So just as a brief reminder then of what we did, again, I like to draw it each time to really make sure I know kind of what's what. So we've got a volumetric flask. We're being told we've got 16.95 grams of our iron sample. So it's, we don't know how much iron is in there, okay? And we're going to make that up to 250 centimetres cubed. All right, with just distilled water. We are going to take 25 centimetres cubed aliquots of it, okay, in a conical flask. And we're going to add, remember, our excess potassium iodide. All right, we're going to acidify it. We're going to let that reaction happen, all right? So equation 1. We're then going to take then our resulting solution, all right, which will have turned, remember we're always looking kind of for what's going on with our reaction. We're going to have made iodine, we're going to see that, aren't we, okay? So we're going to take this and we are going to titrate it with our sodium thiosulfate, all right? And this time it's 0.133 molar concentration, and we're being told it took 26.45 centimetres cubed because, again, we've repeated it till we got those concordant results, and that's what our mean came out as, okay? So remember, we've got to remember, we're working out the moles for 25 centimetres cubed, so we're going to have to times by 10 later on. So again, I'm going to get rid of all this, okay, and we'll just concentrate on the numbers now. So remember, the first thing we can do, step 1, is calculate our moles of thiosulfate, all right? So our moles of thiosulfate, we have got a concentration and we've got our volume. Yeah, remembering our McVitie's triangle, so MCV. All right, so we're going to do our concentration times our volume. But remember, our volume has got to be in decimeters cubed. All right, so our first one then we're doing 0.133 times our volume. But we need that in decimeters cubed, all right? So we get our moles to be around 3.518 times 10 to the minus 3. Okay, so 3.518 times 10 to the minus 3. Remember, keep your numbers full on the calculator, all right? But by all means, round when you're writing it down. So we've got this many moles of thiosulfate this time, okay? So if we look at equation 2, we've worked out our moles of this. We want to know our moles of iodine, because that's our linking thing, isn't it, between the two equations. So this time we've got a 2-to-1 ratio. So to work out my moles of iodine in equation 2, in equation 2, all right, I just take my moles of thiosulfate and I divide it by 2, because it's a 2-to-1, yeah? So 3.518 times 10 to the minus 3 divided by 2, all right? And we get 1.759 times 10 to the minus 3, all right? That's me rounding it. Remember, keep it full on your calculator. So we know how many moles of iodine we've got, yeah? And we've got to remember, haven't we now, to get our moles of iodine here, it's just the same, yeah? All the iodine that there is was created here during this first reaction, yeah? And we're taking all those moles down to our second equation and just performing another reaction on it, okay? So we haven't created more iodine on the way, all right? That is all we've got. So it's all we've started with. So if I've got 1.759 times 10 to the minus 3 here, that's how much I've got here, all right? So my moles of iodine in equation 1 is just the same, okay? So we'd have 1.759 times 10 to the minus 3, all right? So now I know my moles of iodine here. This is the one I'm wanting to work out, my iron 3 plus ions, all right? Again, look at the ratio, it's a 1 to 2, so I need to times my moles by 2 this time. So 4 moles of my iron 3 plus ions, okay, is my 1.759 times 10 to the minus 3, but I'm timesing it by 2 just because of my ratio, all right? So I end up with, it's the same actually, isn't it, as my thiosulfate, okay? So I've got my moles of iron. The whole point is I'm wanting to work out what the percentage of iron is in my sample, all right? So the next step for this question here is to work out the mass of it from these moles that I've just calculated, yeah? So we're going to need the mass of Mr. Mole. So we've got our moles, so we need to times it by the Mr. of iron. So all we need to do is look at the periodic table to find that the Mr. of iron is 55.8. So the mass of iron, okay? So the mass of this will be my moles times my Mr, okay? Which I'm going to use 55.8 for, all right? So this equals 1.963 grams. All right? So out of a possible 16.95 grams of my impure sample that I started with, okay, 1.963 grams happens to be iron. So to work out my percentage of iron in my sample, all right, so 6 is actually finally answering the question. So my percentage of iron in sample is 1.963, okay, out of a possible 16.95 grams happen to be my iron, and I times that by 100 to get it into a percentage, and so it ends up being 11.6%, okay. So that's how you do that question there. So that is the first question on the question sheet that we've asked you to do from the VLE, all right? So have a go at that one, work your way through the rest. Again, if you're still struggling with these, just let us know and we can do some more tutorials for you. Okay, thank you.